Here we go. We're taking a look at lesson 19, and this time it's division, but without really looking so much at kind of the estimation that we were using before and thinking about our math facts as much and as directly, because this time around we're looking at, as you can see in this example for number 1, kind of the standard algorithm, or as I've often called the parent method. This one, I'm not actually going to start with this. I am going to go ahead and move on, and we're going to start with a word problem. And the reason why is because it's got a good story. When you're thinking about a division problem, a couple of different things that we've talked about in class before, and I'm going to give you an example of it here. It's kind of like, whoa, hang on one second. If we were looking at this one, a shipment of 288 reams of paper was delivered. Each of the 30 classrooms received an equal share of the paper. Any extra reams of paper were stored. After the paper was distributed to the classrooms, how many reams of paper were stored? So if we take a look at this and using that tape diagram idea that we've used in class lots of times, we can go through and we can take these numbers of paper and we can say, okay, here's our school. And it's just a really big, long hall. We've got dots in here because we've got a total of 30 classrooms, 30 altogether. And we don't need to go through and kind of label them all. We just kind of need a picture. And we have to take 288 reams of paper and we have to share them evenly to make sure that all those teachers, because teachers are nice, they each get the same amount of paper. And then we've got our storage shed over here where we're going to keep anything extra. So when we think about this, and you guys know what a multiplication problem looks like, addition problem, subtraction problem, you put the big number on top, 288, and then we put the smaller number down below. That doesn't work with division. And here's why. You want to take the amount that you're breaking up into parts, and it goes inside of its own structure. 288. And then what are you dividing by? You're dividing by 30. So it goes on the outside of the structure because it's not what you actually have. So this would be kind of like you putting your hand over what you have to work with. As you kind of go through math over time, I'm going to erase this because it's a no. If we were saying 288 minus 30 or plus 30 or times 30, that would work, but we can't do it when we're dividing it because it's kind of like something that you actually have that you are breaking up into pieces. So to think about how we can do this, if you wanted to think about it again as what we were doing before, where if we have 280 divided by 30, and remember we were able to cancel out our zeros, it's kind of like dividing by 10 to start with to reduce our place values. We think 3 times what gets us close to 28. I know that 3 times 9 gets us 27. Let's try that. And I'm going over the 28 here, which is incorrect, right? Because that's what we had here after we eliminated our zeros, but we haven't eliminated our zeros here yet. So we can't put it above 28 because 30 does not fit into 28, does it? 30, we're looking at 288, and we're trying 9 just as a start. 9 times 0 is 0. 9 times 3, like we just talked about, is indeed 27. So look, 270 is smaller than 288, which is good. If it's 30 or greater, less than the other one, then this could be bigger, couldn't it? So now when we find our difference, that's an 8. 7 plus 1 gets us 8. or 8 take away 7 relieves you 1. So here's 18. So every class can get 9 each. Here's our leftover. Here's what is remaining. So this 18, and we'll go with a different color. Let's get to our colors here. We can go from orange to black because we have our official answer now. This is going to be 18 here, and we can put 9 here. And then we have to answer the question. After the paper is distributed to the classrooms, how many reams of paper are stored? Here we can say 18. We've got to spell reams correctly because it's right in front of us, right? Reams of paper is stored. And that answers the word problem question right there. That's the only question mark that they give us is right here. How many reams of paper is stored? So we're done with that one. Let's go and take a look at just the ones that have no stories with them. And again, you want to get into the habit of when you read the numbers, you read the problem, it's the first number divided by the second number. And so the first number is what you have. It gets kind of under your hand. So if you pretended that this is the back of your hand and these are your fingers kind of going over the top, that's one way to look at that little shelter. So what they did here is they thought, okay, so if we go 2 times 3, it gets us 6. So thinking of it again, like the dividing by 10 idea. So we can then check our work, and that's what we're going to be doing this time around. So let's go ahead and take a look at B here. This one we have 90, and it is divided by 40. Now when I think about it, and I go, well, what if those zeros weren't there? 4, and I can do my counting. I can say 4. If I double that, I get 8. If I triple 4, 3 times 4 gets me 12, which gets us too big. So we have to say times 2. 2 times 0 is 0. 2 times 4 is 8. What do you add to 80 to get to 90? 10. 0 minus 0 is 0. 9 minus 8 is 1, or you can look at it backwards. Go 1 plus 8 gets you 9. So our remainder is 10. Now when we go to check our work, there's some fancy cursive for you. I'm getting the hang of this little tablet, I do believe. When we go to check, let's look at how they did theirs. They said 20 times 3 gets you 60, and then if you add your remainder, it gets you what your dividend was. So in our case, we're going to go, what's our divisor? Our divisor is 40. In our quotient, we have a 2, and that gets us 80. Now we take that we have so far, because we're not all the way to our dividend yet. We take 80 and we add our remainder, which was 10. When we add those together, we get our dividend right here. So those match. So we're good to go. Let's go and do E or F. Let's do F because it's the hardest one. So on this one, we know we happen to have, what do we have? It goes in here, 346. Because when you read it out loud from left to right, 346 divided by 80, dividing it by 80. And we think, okay, what if we divided by 10 and we got rid of our zeros? 8 times what gets us close to 34? I know 8 times 2 is 16. I know 8 times 3 is 24. And then I know if I add 8 more to this, 6 gets us to 30, and then there's 2 extra. So that's going to be 8 times 4 is 32. 4 will get us there, won't it? Let's do it. 4 times 0, 0. 4 times 8, we just figured it out. It is 32. Find our difference. 6 minus 0, 6. 4 minus 2, 2. And that's it. There is nothing more to bring down over here. If you wanted to, and you don't do it on this one, because this one's really looking for that whole remainder thing, but we've done it in class where you put a decimal here, and then you're thinking 8 into 26, which you'd use your 24, and so on. But we don't have to do that this time. We're just going to call it a remainder. Here's what's left, the extra storage. And then to check it, you do it backwards. You take your answer. You multiply your answer by your divisor. So you take your divisor, you say times that whole number in your quotient, times 4. 4 times 0 is 0. 4 times 8 is 32. Now we take that much of it, we say 320. We add our remainder, which was 26. 26 equal to 6 plus 0 is 6. 2 plus 2 is 4. And then the 3, there's no hundreds to add to it. So we get 346. We had 346. So the reason why I did that one next was to kind of be able to show you, oh, okay, so this one, here we go, we've got a number divided by 40 has a quotient. So a number divided by 40. So here's your number divided by 40 gets you a quotient of 6 with a remainder of 16. So what this would look like in algebra form would be x, you don't know it, divided by 40 is equal to 6 remainder 16. And so when we checked it, you remember what we were doing? We were multiplying these two. So we'd say our divisor times that. 6 times 0, 0. 6 times 4 is 24. And then we take that much and we add our remainder, remember? 240 plus 16. 6 and 0 is 6. 1 and 4 is 5. And we have no other hundreds, just that. So that tells us right there that this is what x is equal to. There. All right. So for your homework tonight, I'm going to ask you to please pick one of these two division problems right here. Work it out, parent style. And check it. There you go. Thanks.